Good morning everyone. Today's topic is a problem on periodic function. The given problem is in different types, two types. That is nothing but in that the constants are only change. And in one case, the function can be defined in set form. In another case, the function is defined in partition intervals, in two intervals. In such cases, how we can find out the Laplace transform of the periodic function. Okay, I am taking one problem and how we can find out the Laplace transforms periodic function. Okay, the problem is find L of f of t where f of t is given by f of t equal to t from the limits 0 is less than t is less than b, and f of t equal to 2b minus t, limits b is less than t is less than 2b. Here 2b being the period of f of t. Here 2b being the period of f of t. The same problem can be asking in another way, that is find the Laplace transforms of the function f of t equal to set of t such that 0 is less than t is less than a minus t plus 2a from a is less than t is less than 2a. Here 2a being a periodic function. Okay. The two problems are same but the constants are different. Here the function can be defined in the limits from 0 to b and b to 2b. In the second one, the function can be defined 0 to a and a to 2a. Here the functions are same. In the first interval the function is t. In the second interval the function is minus t plus 2a or 2b minus t. Both are the same functions. Good. Here only the period is different. In the first case 2b is a period of the function f of t. In the second case 2a is the period of the function f of t. Okay. Now we can find out the Laplace transform of the given periodic functions. This problem can be solved by the using of periodic function theorem. Okay. By the periodic function theorem, periodic function theorem, the Laplace transform of the function f of t is equal to 1 by 1 minus e power minus st. Here capital T is the period from the integral 0 to t e power minus st f of t dt. It is the theorem statement of the periodic function's Laplace transform. By using this relation we can find out any one of the case. Okay. The first one is solution. Given that what is given, the given function is given function f of t is equal to set of t such that 0 is less than t is less than b, and second one is 2b minus t from b is less than t is less than 2b. Here where 2b being a period of f of t. That is nothing but here capital T is equal to 2b. This can be applied in the theorem statement of the periodic function. L of f of t is equal to 1 by 1 minus e power minus t is 2b as integral 0 to 2b e power minus st f of t dt. But the function can be divided into two partitions, then the integral can be divided into, that is separate into two integral parts from 0 to b and b to 2b. It is equal to 1 by 1 minus e power minus 2b as integral 0 to b e power minus st. The function f of t is equal to t dt plus limits b to 2b e power minus st 2b minus t into dt. Okay, the integral parts can be write separately into two intervals. One is 0 to b, another one is b to 2b. Now find out the integration of two parts, that is equal to 1 by 1 minus e power minus 2bs. It is in the form of uv. U is e power t, v is e power minus st. The formula of integral uv dv equal to integral uv dx equal to u integral v dx minus integral u dash integral v dx whole dx. By using this relation, we can find out the integration. Here, u is equal to t into e power minus st integration e power minus st by minus s minus integral t differentiation is 1. Integral of e power minus st is e power minus st by minus s into dt. Limits from 0 to b. Plus from the second integral 2b minus t into e power minus st by minus s minus integral 2b minus t integration differentiation is minus 1 e power minus st by minus s into dt. Limits from b to 2b. That is L of f of t is equal to 1 by 1 minus e power minus 2bs, and applying the limits, upper limit is b e power minus bs by minus s, minus into minus plus 1 by s, again e power minus st integration is minus st by minus s. Limits from 0 to b plus, it is minus, right, minus 2b minus t into e power minus st by s, minus into minus plus, plus into minus minus, again e power minus st integration is e power minus st by minus s, minus into minus plus. Limits from b to 2b. Now applying the upper limit and lower limit. 1 by 1 minus e power minus 2bs. Here upper limit is b b e power minus sb by minus s. Here minus 1 by s square e power minus sb. Again minus into minus plus 0 into e power minus s0, that is 0, minus into minus plus 1 by s square e power minus 0. Two upper limits, two lower limits. Minus 2b minus 2b into e power minus 2b s by s plus e power minus 2b s by s. One s and one more s, s into s square. Here s square. Next lower limit, minus 2b minus b into e power minus bs by s minus e power minus bs by s square. That is equal to 1 by 1 minus e power minus 2bs. Here minus b by s e power minus sb minus 1 by s square e power minus sb plus 1 by s square. It is 0, minus into plus minus e power minus 2bs by s square minus into minus plus 2b minus b plus b by s e power minus bs minus into minus plus e power minus bs by s square. Here minus b by s plus b by s get cancelled, is equal to 1 by 1 minus e power minus 2bs. Here minus 1 by s square minus into minus plus, here is minus 1 by s square e power minus sb, 2sb plus upper limit minus lower limit. It's minus upper limit. Here minus into minus plus, plus into minus minus. Again integral e power minus st integration is minus. Why? Because minus is taking outside, again minus will come. Okay, here upper limit minus lower limit. Upper limit minus into minus plus lower limit. Here it is equal to minus bs. Here minus into minus, it will be plus. Plus minus 2bs by s square. Here minus e power minus bs by s square. Again minus bs e power minus sb minus 1 by s square e power minus sb 1 by s square into 1. Here it is 0, minus into minus plus e power minus 2bs by s square. Here minus into minus plus b by s e power minus sb minus into plus minus e power minus bs by s square. Why? Because here negative is come. Okay, here these two are get cancelled and it is minus 1 by s square, it is also minus 1 by s square, and 1 by s square minus 2 by s square e power minus sb plus e power minus 2bs by s square. It is equal to 1 by s square right outside, 1 minus e power minus 2bs into 1 minus 2 e power minus bs plus e power minus 2bs. It is equal to L of f of t equal to 1 by s square into 1 minus e power minus 2bs into, it is in the form of 1 minus 2 into a is 1, b is e power minus bs plus e power minus bs whole square. It is also can be written as 1 minus e power minus bs whole square. 1 square minus a square minus b square form, a square minus 2ab plus b square. It is equal to 1 by s square into 1 minus e power minus bs into 1 plus e power minus bs. It is in the form of 1 minus e power minus bs whole square. 1 minus e power minus bs, 1 minus e power minus bs get cancelled. It is equal to 1 minus e power minus bs by s square into 1 plus e power minus bs. In the numerator and the denominator taking common e power minus bs by 2. So multiply with e power minus bs by 2 is taking outside means it will come in the denominator, that is taking to the numerator, it is e power bs by 2, and multiply of these two it will get 1 minus e power minus bs by 2 by s square into e power minus bs by 2 into e power bs by 2 plus e power minus bs by 2. E power minus bs by 2, e power minus bs by 2 it cancel. It is equal to 1 by s square into 1 e power bs by 2 minus e power minus bs by 2 by e power bs by 2 plus e power minus bs by 2. It is in the form of tan h inverse x, tan hx, that is h bs by 2. It is the solution of the given function's periodic function Laplace transform. Okay, the first thing, split into two integrals if the function is given in the two partitions, and simplify the integration and applying the limits, simplify, then we are getting the 1 by s square into tan h of bs by 2 is a Laplace transform of the given periodic functions. Okay, thank you.